Hello Algebra 1, this is lesson 4.7. We were working with making predictions with linear models. Remember, a couple days ago we learned in 4.6 of lines of fit, and that's where we drew the data points out on a coordinate plane, and then we just estimated a line of fit. And it's a good estimate, a good way to maybe make predictions with that, but it's just that, it's an estimate. Yesterday, in our activity on page 271, we did what we call linear regression, which is something that a computer can do for us to calculate the best line of fit, and we call that the best fitting line, at least within a certain margin of error. We call that the best fitting line that will approximate that data. And so today, in lesson 4.7, we're going to use the line to make predictions and estimates. Now they kind of break this up into two different categories. If we're working inside of our data, so maybe we have something, we know x is our 1, 2, 7, 8, 9. So if we're working between that 2 and the 7, then we call that linear interpolation. Linear interpolation. And that's whenever you're working inside the data that you already have. Whenever you're working outside that data, meaning the biggest number maybe is 9, and you start making predictions about 10, 11, 12, or maybe like predicting in the future, we call that linear extrapolation. Okay, it's really the same thing. It's just using that line of best fit, or that best fitting line, to make predictions. Now, when we do interpolation, that is generally considered to be pretty accurate because it's within your data that you already have collected. When we do extrapolation, the further you extrapolate, or meaning the further away you get from your data, it tends to be less accurate, and we'll see that more here in a minute. So if you look at example 1, it talks about CD singles, how many were sold in a particular year. This data is for really old data, whenever I wasn't that old, for 1993 through 1997. And notice this is talking about millions of CD singles shipped. In 1993 is 7.8. So we have three things I to do, A, B, and C. First of all, make a scatter plot of the data, which we already know how to do, going there into your stat plot and editing that and entering those data in there. And just to make our lives a little easier, we're going to use 0 to represent 1993. That's our first data set. And then we're just going to talk about how far away it is from 1993. Since 1995 is 2 years away from 1993, we're going to use 2 to represent that. 96 is 3 years away, so we use 3 to represent that. 97 is 4 years away from 1993, so we use 4 to represent 1997. And you get these data points like this whenever you graph that. For part B, we're going to do a linear regression, and we get this equation here, y equals 14x plus 2y. And then for part C, we go in, we're going to graph this, go into your y equals, enter this, and then you'll get this graph over here that we're showing up in part C. Now to find what they're asking us in part C is to say, hey, how many shipped in 1994? Now notice that's between these two. So this is interpolation. Okay, it's between these two data points. And so we're going to go to the table, which is second graph. Graph is right underneath the screen over here on the right. And then it's going to take you to a table. And since we're looking for 1994, that would just be 1 year after 1993. So we're going to look for x equals to 1. So you scroll up or down so you can find that, and you find a 16.4. Okay, so that means in 1994 there was about 16.4 million CDs were shipped or sold. There. Now, if we want to take the same data, the same information that we have gotten, we're going to go ahead and make an extrapolation on that. Make predictions about after or outside of the data that we have. Since we're wondering about 1998 and 2000, so we're going to we already have that information in our calculator, so we're going to go second graph, which is that table again, and look for x equals to 5, because that's 5 years from 1993, and x equals to 7, because that's 7 years after 1993 for the year 2000. And we get these numbers, 72.4 and 100.4. Okay, so those are our two answers for part A. For part B, it asks us it tells us some information. It actually says, in 1998, 56 million CD singles were shipped, and in 2000, there are 34 million CDs that were shipped. Okay, and so what we see is that our estimate was about 72 million, but the actual amount was 56 million. Well, when we subtract those two, that means we are 16 million off from the actual number, right? Our prediction was 16 million off from the actual number. And for the year 2000, we notice when we say 100 minus 34 million, that we're 66 million off. And so notice our line of best fit is not fitting the data very good for things outside of the data that we already have. And so you can see the further away that we get from the information we have, the less accurate that prediction becomes. Now, the next thing we're talking about in this section is zeros of a function. And now you're like, oh man, we're learning something new. But actually, we're not learning something new. We're just learning a new name for something we already know how to do. So a zero of a function is the x value for which the function is equal to 0, or really what y is equal to 0. Well, if you think visually on a graph, if we're looking for y equals to 0, that's somewhere along this line, or what we call the x-intercept. Okay, we've already found x-intercepts before, or we've also been able to solve equations like this, right? 2x minus 4 is equal to 0. We can solve that. Add the 4 across, divide by 2, we get x equals to 2. We can find the x-intercept of something like this, y equals to 2x minus 4. Oh look, that crosses right there at 2 on the x-axis, so the x-intercept is 2. So really all we're doing is changing the name. And so whenever we are finding the x-intercepts, or finding the zeros of the functions, we're really doing the same thing. So we're just saying, hey, when does this function equal to 0? So we're going to replace that f of x equals to 0 and solve, which we did right over here, or we did here visually. So we're going to go ahead and try one of these. It says find the 0 of the function f of x is equal to 1/8 x plus 2. So the one we're wanting is, when does f of x equal to 0? Well, let's find out. So we were saying 0 is equal to 1/8 x plus 2. So we're trying to isolate that x, so I'm going to subtract 2 from both sides. Those two go to 0. 0 minus 2 is negative 2. It's equal to 1/8 x. We're going to go ahead and multiply the right-hand side by 8 over 1 to make those reduce. When we do to one side, we must do to the other. 8 over 1. And so we find, coming up here where I have more room, that 1x is equal to, well, we're saying 8 times negative 2, which is negative 16 divided by 1 times 1, or 1. So x is equal to 16. So the 0 of f of x is negative 16. The 0 of f of x is equal to negative 16. If you haven't seen it already, your homework starts on page 278, unit number 3 through 12 all. So you're not skipping, just doing the even ones like we normally do. Today we're going to do 3 through 12 all. And yes, that is only 10 problems. I hope you don't mind too much. Good luck, guys.